Hello everyone, it's Francesco Ganora here with a new Mule4 video. This one is about the anonymization of data and messages. Anonymizing means to hide a certain personal or confidential information in the message. So for example, we have in this JSON document containing user data, names, addresses, phone numbers, etc. would like to hide certain fields or mask them. So the anonymized an anonymized version of this message would be what you can see here, where you have certain fields replaced by the string placeholder, in this case a secret. So and also some names of friends are replaced by generic identifiers. So this is a problem you've come across for sure in your integration experience because of the legal requirements in Europe. For example, we have the GDPR law for privacy that mandates anonymizing data, among other things. So let's proceed to see what techniques we can use in Mule4. One interesting, so traditionally, what we would need to do is to have some kind of functional recursion on the message payload because the message can be complex, can have nested structure, nested arrays and objects. So we need to recurse over those parts in order to find the fields that we need to replace with a generic placeholder. If we go to the MuleSoft documentation, we see that there is a Mule4.3, a new update operator. You can see in the Mule documentation here under DataWeave reference, DataWeave operators, update operators, and it shows how you can achieve the same effect that you could with the traditional code you can see here, which uses map object, with a new easier notation uses the update operator with containing a list of case statements. The case matches a path that we can see here, and then the value of the data element of this path is saved into a variable, and then you can replace this value with an expression using the old value. So in this case, to increment the age by 1. But of course, in our case of anonymizing means replacing the value with the placeholder secret star secret star. So this is a very interesting addition to the DataWeave language, but it has some limitation because if we scroll down, the type of operators, the selectors that we have are we have the value selector, which allows us to drill down into nested objects, or we can have an index selector where we can select the particular elements of arrays within our message. We have attribute selector that will be used in case of XML messages, and we have a dynamic selector then where we can resolve the path dynamically. Unfortunately, there is no multi-value selector, so we cannot just easily iterate into an array. So we need to still, it's not really possible, at least as far as I know, to write a generic code that traverses a message structure with this operator. But if we have a specific case, we can easily use this technique, but on a specific case, not generic. So that I'll show you in the first flow of this project called anonymize demo, which I put on GitHub. I'll, of course, as always, put the URL of the GitHub, this GitHub repository in the description of this video. Let's go into the XML configuration file, a specific anonymized demo that is just HTTP request calling this transformer, and just a minute. So you can see here that because the JSON we have to work on contains at the top level an array of objects. So an array, each object is a user. You can see this this array. So it contains several objects. Each object is a user. We need in any case to use a map operator to iterate over these objects in the array because there's no, the update operator does not have a multi-value selector. So when we do that, then with dollar representing the current object we're working on, then on that object we can use the update operator to replace different fields, name, balance, age, email, phone, etc., with a placeholder. Placeholder is a variable that whose value is our secret, is the masking value. So you can see that we cannot just use the update operator. If we look at the list of friends, suppose we want to also mask the information of the name related to the name of his friends. Then we have for each user another array and another array of objects. So again, we need to take an ad-hoc approach here, and then use a nested map operator on the friends. You see, for each when the update matches field friends within the current user object, then we map each friend sub-object which can just contain an ID and a name in an anonymized object. So we map it with friend number, friend 1, friend 2, etc. So you can see this is a specific. We use the update operator, but we need to use it mixed with traditional map operators because we cannot generically traverse a complex object structure by just using the update operator. So obviously the example in the Mule documentation is really trivial. Example you can see here. So this is just an object with 3 fields. So that's not a realistic example. Okay, so I already ran the embedded engine, and so I can test this out. I can test this out with a specific anonymized JSON from my Postman client, REST client. So I'll put a post request to the URL exposed by this flow. So this is the URL. This request is the original JSON object, and then I get the same JSON object as a response with the different fields replaced by this secret placeholder. So this, as I said, is what you would do normally In most cases, if we use the latest version of Mule, so Mule runtime, which is 4.3, to use the update operator, which is quite convenient. It's just that if you have a complex message structure, you would need to build something more complicated here, but still it will not be really as complicated as remapping the whole structure. So the update operator allows us to change parts of a complex structure without remapping everything. That's the essence of it. Let's go to the other case, which is the generic anonymization. This is uses the functional recursion technique that was present already in earlier versions of Mule, so nothing special here. It's just that there'll be a bit of a twist here because I want to show you how to make things a bit more generic. So this flow here, the private flow, generic anonymized flow, has a choice router that branches on the type of payload, XML or JSON, or only these two types are supported. Otherwise, we throw an exception. And what this does is to call a DataWeave in a module. So this is also to show the use of modules where we can reuse some bits of DataWeave. So this module is imported, it's called anonymization, is imported from the modules folder. You can see in the main resources has a subfolder called modules. I've defined here the anonymization DataWeave file. And this can be reused within the Mule application. It's also important to remember that if these modules could be packaged in dependent projects. So if you have a module in a dependent project, you can export it in a jar and place it into your dependency repository, into your Maven repository, like for example Nexus, a local repository for development, but then normally a repository like Nexus, and this becomes a normal Maven dependencies. And when this dependency is added to your project, then also this DataWeave module become available to the project that imports this dependency, that uses the dependency in the POM file. So this way we can define the reusable pieces of DataWeave. Now let's look at these two DataWeave function in the module. The function to be called from the the DataWeave transformer is called anonymize. This is just a helper function. You can see it has three input parameters: invol, anonymize value, and fuse to anonymize. The invol is the input message, let's say, input value. Anonymized value is the value to be replaced, that will mask the values to be anonymized. And the fields to anonymize would be an array of strings where we have the names of the fields to be replaced with the anonymized value. So we have in this other JSON document, this array of field names will be input to the function. This is just not to hard code it in the function, in the code. Of course, it's configured through a file. Okay, so this calls the doAnonymize function with a for parameter which is false. This value false, this Boolean value input at the end is used during the recursion. This doAnonymize is a recursive function that the first takes the whatever is passed by the caller. It could be the payload or something else. So involve will be the initially the message, the whole message. Then this function proceeds to with the match operator to check the type of the input value. So if invol is an array type, as in our example, it is the top level message is an array, JSON array. We use the map operator to iterate, to scan, to iterate through the array, and we apply recursively the anonymize function to all the elements in the array. So obviously an array is not a simple value that can be replaced by the generic placeholder. So only a string we assume for this this function assume the only a string can be replaced with a placeholder. So then for each element of the array we have a recursive call. Let's suppose that inside there is an object. Then if the type is an object, we use the map object operator to iterate through the key value pairs of the object. But here, within the object, we could have another object, we could have an array, but we could also have a simple value, such as a number or a string. Here we assume that, again, it's a simplification, that the values to be anonymized can only be string fields. So we, if the key, when we iterate of this on this object, if the key, so the field name, is contained into the array of the fields to anonymize, so it's if is one of the fields whose value must be masked and must be replaced by the placeholder, then we call the doAnonymize recursively with the value true. So it means that it needs to apply the anonymization. Otherwise, for example, if the object key is anything else than a string, we call recursively with the value false. So in the end, the recursive calls will find simple fields, which are strings or numbers or dates. And then if it's a string, then at this point, if the last parameter, apply anonymized value, the fourth parameter was set to true, so if it's a string field whose name was in the list of the fields to anonymize, then we replaced with the anonymized value. So we replace with the placeholder. Otherwise, we copy the value. If the type is not a string, if it's a number or a date, for example, we just copy the value. So this recursion works, well, it has, apart from the limitation that the anonymized value can be only string values, there's a couple of other limitations. There's, of course, a limitation that if we specify name, it will anonymize all fields, name fields throughout the structure, independent of where they're found in the hierarchy. This is one limitation. The other limitation is on the XML attributes. So, of course, for simplicity, this works in many cases. So it's a good starting point for your development. So let's see how it's used. Used very simple. So we call the anonymized function with, in this case, with a payload, and with the placeholder value to be replaced, and the field to anonymize. Here I'm using a technique which is practical. Before calling the generic anonymized flow, the private flow that does the work from the main flow, what I do is I set a variable which contains the other parameters. So one piece of data that is passed to the private flow is the payload, which is the main the data to be processed by the anonymize logic. But the parameters of this anonymization are the content type, because we support we have things a bit differently for XML. You can check for yourself in the XML. And the placeholder value, which is set here, and also the field to anonymize. I've shown you this JSON document. This JSON document is just read. Via the read URL function. So it's just read dynamically here. It's read from the resources, main resources folder, so anything which is in the class path. So in this way, we pass to the private flow these three variables, and then at the end of the private flow, we remove this variable. This is a technique which is useful to have a clean passing of data needed by a sub flow, or it's a private flow, child flow, let's say. And then cleaning up at the end of the child flow, we clean up. So it's easier if the additional values which are needed by the child flow are enclosed in a object, and then so they're passed as a single variable, and then this variable can be removed. So okay. Let's test the generic anonymization from the Postman client. I have here a request to anonymize with JSON. It's post request. It goes against the test generic anonymize endpoint, where the body is our usual JSON, where we want to anonymize these four fields that we saw before, like balance, account balance, name, email, phone, and address. And the header passes, of course, content type application/JSON. I have still my app running in Studio, so I'm just submit this request, and then you can see indeed we have anonymized the fields that we wanted here. You can see they're replaced by the placeholder. Compare with the specific anonymization we've seen earlier with the update operator. Here you see here the name fields of the friends are anonymized with the same string, whereas in the specific approach using the update operator, I could do something more sophisticated here. Regardless of where the name fields appears in the structure in the message, I will just replace it with the same placeholder. Again with XML, let's test it. Same endpoint. This time with content type application XML. And then we have again same result. So we have anonymized the same fields, the same elements. As I said before, this module will not work anonymizing values in XML attributes. One last thing before I leave you is that there's also a couple when you clone the repository for this new project, you will also find a couple of a unit test here. So that then you can check for yourself. They'll also check the results of this execution, at least for JSON, against the expected results, which are in under source/test slash resources slash expected test results. So okay, that's it. Please clone this little project and then test for yourself, and then evolve this logic so you can use it for your daily work when this use case comes up. Bye, and until the next video. Bye bye.